Welcome back, Focus Learners. I'm your master critic, and today we are stepping into the grading room for a massive grade makeover kitchen audit. If you're preparing for the Cambridge AS and A-Level Mathematics 9709 paper, specifically targeting algebra and those notoriously tricky modulus functions, you are in exactly the right place. Our goal today is absolutely crucial. We are going to dismantle a messy, failing Cambridge response and rebuild it live, transforming how you cook up your equations from the ground up to secure those top marks. Okay, let's dive into this. It's the central question we have to ask ourselves. Why do otherwise brilliant students lose such easy marks on modulus functions and their inequalities? Let's look at the sour ingredients. Imagine my two apprentices in the kitchen right now. We've got Alex, who always overcomplicates the recipe with unanalyzed facts, and Sam, who rushes the writing process and forgets crucial structural steps. We see this constantly. You know the basic rules of absolute values, yet time and time again, exam papers come back with slashed marks. It's a core problem, and trust me, it is almost never about raw mathematical ability. I want you to look at this quote straight from a senior examiner's insights. Most students lose easy marks on algebra, modulus functions, but after this, you won't be one of them. That is a massive promise, right? And we are absolutely going to deliver on it today by revealing exactly what the examiners are desperately looking for when they grade your paper. To achieve this intellectual makeover, here's our agenda. 1. The modulus mark trap. 2. Mastering core principles. 3. The method mark strategy. 4. Auditing examiner red flags. And 5. The final exam blueprint. Let's get cooking. Section 1, the modulus mark trap. Let's start dissecting the disaster. Why is evaluating mathematical evidence and drawing structured conclusions so incredibly hard? This is where the trap snaps shut. Take our apprentice Alex. Alex aims for superficial breadth, trying to memorize 100 different variations of modulus inequalities without understanding the engine underneath. But Cambridge prioritizes analytical depth. If Alex and Sam were critiquing a bad response line by line right now with a digital red marker, they'd realize the lack of applying command words completely ruined the score. Examiners want to see logical, structured reasoning, not just a bunch of math thrown at the wall. Section 2, Mastering Core Principles. So the crucial point is, to escape that mark trap, we need to establish the theoretical foundations. What Cambridge demands is connected understanding. Think of it as a master flavor profile that is completely transferable to unfamiliar contexts. Top-performing students don't just memorize algorithms. They develop a systematic analysis they can apply whether they're facing a simple linear equation or highly complex modules quadratic. Look at how the syllabus breaks down your grade into 3 tiers: descriptive, analytical, and evaluative. Anyone can be descriptive, like Sam, just naming ingredients and identifying key elements. But to reach the analytical and evaluative bands, you must question assumptions, compare approaches, and ultimately justify your decisions with clear evidence. In math, evaluating evidence means recognizing the assumptions you're making when you square both sides of an inequality, identifying limitations, and understanding alternative routes. Section 3, the method mark strategy. Let's pause the monitor right here. Listen, if you want to stop serving up average grades and unlock the secret recipe for an A-star, subscribe to Ace the Exams at the handle @AceTheExams right now and hit that notification bell. Okay, let's resume. Alex and Sam are trying to rewrite a bad block of working, but they've hit a massive roadblock with their logical flow. So I'm stepping in to rescue the text. Here is our 5-step recipe to completely standardize your approach. Step 1, deconstruct the question. Step 2, extract the relevant data. Step 3, select your analytical framework, graphical or algebraic. Step 4, execute with clear notation. And Step 5, present with correct terminology. Marks are heavily awarded for this exact process. And this brilliantly illustrates the need for a systematic processing checklist. You can actually use a math-adapted peel structure here for your logical connections. Point out your method, evidence it with working, evaluate your assumptions, and link to the final valid range. When you face a terrifying absolute value inequality, like the absolute value of 2x minus 3 is less than 5, you don't panic. You just run the checklist. Identify, apply, execute, verify, present. It completely prevents the anxiety of disorganized thinking. Section 4, Auditing Examiner Red Flags. All right, it's time for an interactive taste test. Picture a 60-second visual countdown timer on your screen. Can you spot the winning argument point against a bad answer? Let's pull back the curtain on real examiner reports. Mistake number 1 is the classic trap, using the wrong approach for the wrong context. like squaring both sides when a simple graphical sketch would have revealed the root safely. Mistake 2 is forgetting to check format and presentation. And mistake 3, providing answers not specific to the context given. Okay, challenge 2 for our taste test. There is one hidden critical error in a standard bad paragraph that instantly forfeits 5 marks. Can you guess it? Boom. Examiner alert. Students lose marks by not showing working. Now, what's really interesting about this slide is it sounds so incredibly basic, yet it is the #1 reason candidates drop a full grade boundary. In higher level algebra, the working literally is the math. Read this golden rule carefully. Even if your final answer is wrong, method marks can save you. No way, right? Yes way. If you make a tiny arithmetic error on the final line, but your systematic processing was visible and flawless, the examiner can still award you the vast majority of the points. The method over result approach is your ultimate defensive strategy in the exam hall. Section 5, the final exam blueprint. Let's read out our newly transformed, flawless response. To build this, Cambridge expects strict presentation conventions. We're talking proper headings, correct terminology, appropriate formats, and clear annotation. When you solve a modulus inequality, don't just leave a floating inequality sign at the bottom of the page like Sam used to do. Annotate your valid ranges clearly. Following these rules is the final plating step to a 5-star, undeniably perfect presentation. To wrap up our kitchen audit, here are your key takeaways. Let's call them the 3 golden rules of exam prep. 1. Use a visual story memory hack. Picture the modulus bars as a rigid structure you systematically dismantle using our 5-step framework. 2. Show every single step of your working. 3. Practice past paper questions applying the method mark strategy relentlessly. I'll leave you with this provocative thought. Will you continue leaking easy marks by rushing to the final answer, or will you use the method mark strategy to mathematically guarantee your A-star? The choice and the grade is entirely in your hands. Remember to subscribe to Ace the Exams at the handle @AceTheExams, turn on those notifications, and comment below with the subject and level you find hardest right now. Thanks for joining me on this explainer. Keep your focus sharp, and I'll see you in the next one.